Now we'll study the concept of dense set and nowhere dense set. If X is a topological space and A is any subset of it, then subset A is said to be dense in X if closure of set A is equal to whole X. For example, if X is equal to R is a topological space and Q is a set of rational numbers is a subset of R, then Q is dense in R, because as seen earlier, set of limit points of rational numbers is whole real line, and thus the closure of set Q is Q union set of limit points for rational numbers, which is Q union R, and which is equal to whole R, and therefore the closure of set is equal to topological space X is equal to R, and therefore Q is dense in R. Similarly, set of irrationals is also dense in R. Now we'll define nowhere dense set. Any subset A of topological space X is said to be nowhere dense in X if interior of closure of set A is empty in X. For example, set of integers is nowhere dense in X is equal to R, because closure of integers, that is closure of Z, is equal to Z union Z dash. Now Z dash is a set of limit points, has nothing in it, because if we consider P as any integer, then we are able to draw at least one neighborhood. Actually there are infinitely many, but we are able to draw at least one neighborhood of point P which contains no integer other than P, and this will happen for each and every integer. So set of limit points for integers is empty. So closure of set Z is Z union empty set, which is Z itself. Now interior of this closure is empty, because by the definition of interior, any point X is said to be interior of set A if neighborhood around that point completely lies inside set E. But here if we take any point in X is equal to R and if we draw any neighborhood around it, then it will contain rationals as well as irrationals. So the neighborhood cannot completely lie inside closure of integers. So set of integers is nowhere dense in R.